let's do first price auction. So let's just, again, if you want we can take more players, but let's just take 2 players. So suppose the game is as follows. So it's a first price auction. Suppose valuation of player 1 is V1, okay, and let's say it's fixed and given, okay, and valuation of player 2 is also fixed and given, and both valuations are known to both the players. Okay, so player 1 knows his own valuation as well as player 2's valuation. Player 2 also knows his own valuation and player 1's valuation. In reality, V1 and V2 are not known to each other. I mean, how much I value a product, only I know. It is unlikely that the other player will know that. Yes. Similarly, if you are sitting in an auction, I cannot just look at your face and say that, yeah, you must be having this valuation, right? I cannot, right? Okay, so this is kind of an unrealistic assumption. Okay, that is why there is a better model of auctions, which is a Bayesian game. Okay, where player 1 and 2 don't know each other's valuations. Okay, and they have some probability distribution over the valuation of the other players. But right now we are just doing static games of complete information. So we'll just stick to this assumption that, let's say, 2 players knows each other's valuations. Is that okay? Fine. So set of players is 1, 2. Okay. And then the bids, so player 1 can bid any non-negative amount. Player 2 can also bid any non-negative amount. Okay. So action set of player 1 is R plus. Action set of player 2 is also R plus. Okay. Fine. Okay. So what are the preferences? So basically in first price auction, let's say if whoever is going to bid the higher amount, let's say he's going to get the object. Okay, and it's a sealed bid auction, so you can imagine it's a sealed bid auction is like a simultaneous move game, because nobody can see what you are doing. So you can imagine it's a simultaneous move game, so both players are going to submit the bids. Okay, and the payoff will be realized based on the bids that are submitted. Okay, so if player 1 submits a higher bid than player 2, then player 1 gets the object and pays his own bid. Okay, if player 2 bids higher than player 1, then player 2 gets the object and pays his own bid. And if both players submit the same bid, let's assume that the tie-breaking rule is that in that case the object will go to player 1 and he'll basically pay his bid. Okay, so is that clear? Problem clear? Okay, so let's just write the utility functions now. Okay, so utility function is obviously a function of b1 b2, and you will get the object when you will get the object. Of course you will get the object when you win, and when you win you pay b1 and you get b1. And this is what's going to happen if b1 is greater than or equal to b2, right? Because when the bids are equal, then also player 1 gets the object. That's our tie breaking rule. Okay, and if player 1 loses the auction, then he gets 0. Okay, similarly u2 b1 b2 is v2 minus b2 if b1 is less than b2. Okay, and it is 0 if b1 is greater than or equal to b2. Okay, now you have the payoffs. So I give you 10 minutes, figure out the best responses and the Nash equilibrium. Please note that v1 v2 are fixed, okay, and known to both the players. Okay, Okay, so let me do this. Okay, so first let's find the best responses of player one. Okay, so BR1, B2. So notice that, if player two's bid is more than player one's valuation, okay, then player one would want to lose this auction. Do you agree? If player two's bid is more than player one's valuation, then player one would want to lose this auction. Do you agree? Because if he wins this auction, then he has to pay more than B2, which is actually more than V1. Okay, so the set of best responses will be any bid that leads to losing this auction. Okay, so any bid between 0 and V2 will be the set of best responses. Okay, now if B2 is equal to V1, okay, in this case, well, he's indifferent between losing the auction and winning the auction by bidding exactly V1. So basically, in this case, 0 to B2 close interval is the set of best responses. Okay, and if B2 is if B2 is smaller than V1, then he would want to win this auction, and the lowest bid at which he can win this auction is exactly B2. So in this case, the set of best responses will be a singleton set, which is B2. Okay, now what about BR2, B1? Okay, please note that it's not symmetric, so you cannot do the same thing for player 2. The reason why it is not symmetric is because there is a tie breaking rule which is in favor of player 1. Okay, so you just cannot write, in place of B2 B1 and in place of V1 V2, so you cannot do that now. Okay, so if B1 is greater than V2, okay, then in that case again he would want to lose this auction. Okay, and how can he lose this auction? He can lose this auction by bidding anything up to B1, B1 included. Okay, and in fact, even if V2 is B1, then also he would want to lose this auction, because if V2 is B1, then he can only win this auction by bidding more than V2, and that would mean that he's going to get a negative payoff. So you can actually put an equality sign here. Okay, and if B1 is less than V2, then he would like to win this auction. Okay, but there is a problem. The problem is that there is no best response. Because if he reduces his bid and try to actually come close to B1, his payoff will keep on increasing. Okay, but then moment he bids B1, he loses the auction, so his payoff is going to become 0. Yes, so there is no best response. Is that fine?
Yes, sir.
Okay, now that I've given you the best responses, just plot it. You have 5 minutes, plot the best responses and give me set of all Nash equilibria. So what are the set of Nash equilibria?
Sir,
Okay, so
it's
yeah,
the set of all B1, B2 such that B1 equals to B2 and they're in between V1 and V2.
that's right. Okay, so this is set of all Nash.
Hmm.
Okay, this segment.
Right, sir.
Okay, so let's just check. So if V2 is greater than V1, okay, then in that case, anything between 0 and B2 is the best response. Okay, so let me use gray color for player one's best response. Okay, so 0 to B2. Yes. Okay. Please note that this boundary is not included. Okay. And if B2 is V1, then in that case, anything between 0 and B2, B2 included. Okay. And if B2 is less than V1, then B2 is the best response. Okay. Okay. And in this case, if B1 is greater than V2, then anything from 0 to B1 is the best response. So if you fix B1, B2 will be from 0 to B1, B1 included. Okay, so let me use some other color, let's say blue color. Okay, and let me also put the boundaries, because if B1 is greater than or equal to V2, then B1 is included. So, so if B1 is included, then in that case, okay. So notice that this is where the overlap is. Okay, so set of all Nash equilibria is, is that okay?
Yes, sir.
Okay,